f of a plus f prime of a times x minus a. And this is the linear approximation. The same thing is the linearization, but this is equal. So this will be the linearization of function f near a. It's the same. Now we have to determine f of a, we have to determine f prime of a, and we have to put 0 for a, and f prime of 0 and f of 0. So let's differentiate f of x first. What do we get?
We get 1 over 2 the square root of 4 minus x.
Times?
It would be 4 minus x.
Prime, which is?
4.
4 prime is 0. So when we differentiate negative x, we get?
Negative 1.
Excellent. Very good. So indeed, this is negative 1 over 2 the square root of 4 minus x. Perfect. Now I have to determine f prime of a. So how much is 4 minus 0?
4.
Very good. The square root of 4 is?
2.
2 times 2?
4.
Yes. So we have this, we have x minus 0, and now we have to find f of 0. And we know that f of 0 is?
2.
Very good. Now we put everything together to find the approximation. It's approximately f of 0, we have it 2, plus, in this case, is negative 1/4, and times x minus 0, which is x. Now this equals L of x. So what do we say here? Here we say that the function can be approximated by this line. What do we say on this side? We say that the function that approximates f of x is this. For anything near a. Near a equals 0. Okay, so now we are also asked, I didn't catch that part, Sean, forgive me. We were asked to use the linear approximation to approximate f of?
They want you to find the square root of 3.9.
So the square root of 3.9?
And then also the square root of 3.99.
Okay, so basically, because they are asking us to evaluate this, this is our x, right? So we are close to, so this is basically the square root of 4 minus 0.1. And this is the square root of 4 minus 0.01.
So is that how you, that's the part that tripped me up, is the 4 minus the
Yes,
0.1.
because here's the function, right? So if you ask me, so our function, let me write it here. Okay? So this is the function that is approximated. So we say that the square root of 4 minus x can be approximated by 2 minus 1/4 x. This is what we are saying. This is our function. So when I say that the function is approximately this, I'm really telling you that instead of evaluating this, you can evaluate that. But remember, near 0. So therefore, when you ask me to approximate, use this to approximate the square root of 3.9, you're really telling me this.
That makes
So
sense.
you are telling me that x is 0.1. When you want me to approximate 3.99, you're really telling me, because it has to be near 0. So you are
Okay.
saying this. So in other words, this is approximately 2 minus 1/4 times 0.1. And this is approximately 2 minus 1/4 times 0.01. So the square root, I hope you can see this. Let me see, yes, I think you can. So the square root of 3.9 and 2 minus 0.25 times 0.1. Is that clear?
Yes, it is.
So the same thing here. Very, very interesting question. Thank you for this. So 3.99, and this 2 minus 0.25, I just, instead of writing a fraction, times 0.01. So you have to think in terms of, what does this mean? Well, it means that the function, forget about this, but the function is the square root of 4 minus x. So when I say that the square root of 4 minus x can be approximated by this line near 0, and he asked me to find the square root of 3, approximate the square root of 3.9, I have to change it into what the function is all about. And this is what the function is all about, 4 minus x. In order to get the 3.9, I have to use 4 minus 0.1. In order to get this, I have to use 4 minus the difference, which is 0.01. Because this is what I approximate with this. And x must be near 0. If this number is not near 0, the approximation is not good. I have to use a different linear function that approximated this if I'm not near 0. So if you want to plug in 2 here, the difference, so if you want to plug in 2, which is not going to work, that's not going to be a good approximation. Oh, I didn't write these numbers, but I hope you wrote them, right? So this one, the first one. So the first one is 1.975, and this one, the second one, is 1.9975. Okay, so if you by mistake say, okay, let's see what happens when x is 2. Well, the square root of 2 and 2 minus 0.5, it happens that for this function, because it's a square root, it's not a huge difference, but they're not as close. Because around 2, you will use a different function. At 3 will be even higher error. So remember, we are near 0 because all these were 0. Was there another part to the problem, or is it that's it?
There's a graphing portion to it, but the graphing portion, you could just stick it into the calculator and kind of estimate from there.
So what are we asking with the last part?
It's like illustrate by graphing f in the tangent line, and simply just graphing L of x and then f of x.
Yes, yes, of course. So all you have to do is just put both in the graphing calculator. So we had the square root of 4 minus x and the other one is 2 minus 0.25x. And when, since we want to be around 0, I'm going to change the viewing window. So this is the square root. There is no point in even looking to the left. So 0, let's say to 5, that's fine. 0 to 3. So near 0, if I use the red line, which is the line, or if I use the function itself, they're going to be extremely close. But as you see, as you get further away from 0, they're not close anymore. But at 0, this function is a good approximation. Good, very nice problem. Very good. Anything else you would like to continue with? Anything else?
I've got one.
Yes, please.
Okay, so this is from WebAssign. This is y equals log base 4 of e to the negative x times cosine pi x. I'm sorry, so e to the negative x and then times cosine, yeah.
No problem. That's it?
Yep,
And we're asked to differentiate?
yes,
Okay, so this is basically a product like this.
right,
Am I correct?
yes,
Okay, perfect. So this is a product. I have to use the product rule, function 1 and function 2. So y prime will be, remember the difference between differentiating a natural log. So if I have natural log, I can also change the base here, but there's no need. So it's up to you. So if we differentiate a natural log of a function, we have 1 over the function times the function prime. Agreed with that?
yes,
Now, if I have log in any base of the function prime, what do we get?
1 over
Yes.
the function times the natural log of the base.
Yes, times 1 over the natural log a times f prime. It's only because we changed the base, right? Remember the rule for changing the base. Log base 5 of 3 equals natural log 3 over natural log 5. That's the change of base formula. So that's why we have this natural log a in the denominator.
Okay.
And writing it nicer, indeed, it's 1 over f natural log a times f prime. So then when I differentiate log base 4 of e to the negative x, I have to write 1 over the function times the function prime times 1 over natural log 4, or like this. So 1 over e to negative x natural log 4 multiplied by the inner function prime. So now when I differentiate e to negative x, I do get e to negative x, but times the inner function prime, which is
-1.
negative 1. And of course, you're not surprised I ran out of room because I didn't plan ahead. So times cosine pi x and plus, I'm going to write it one more time. I just don't want to leave it in the middle. I'm going to write it again nicely. Okay, and then I have log base 4 of e to negative x. And now I have to differentiate cosine. When I differentiate cosine, I get negative sine pi x and times the inner function prime, which is pi. So I'm going to write it one more time from scratch for everyone to understand what I'm doing. So y prime equals 1 over e to negative x natural log 4, e to negative x times negative 1 and times cosine pi x. Plus, I copy the first function and times negative sine pi x, which is cosine prime, but times the inner function prime, which is pi. You're not supposed to do anything here other than just eliminate those negatives. Since you can simplify these two, they are the same. So I'm going to write the first part as negative cosine pi x over natural log 4. And I'm going to write all this as negative pi log base 4 of e to negative x and times sine pi x. And you're not supposed or required to do anything else.
Thank you.
Is this better?
I think so. I'm gonna check it because I had something similar, but it was giving me, I hit the practice another version and the answer it gave me was a little bit different.
Yeah,
But-
just let me know if you're having difficulties. We can do it again or something to see what the problem is.
No, I think I had something very similar, but I might have missed a
Maybe a sign or something.
yeah, like a symbol or
Okay.
Where does the negative 1 come from?
This one.
Yes.
E to negative x prime, if this were positive, it would have been e to the x. But it's e to negative x, so it's a function. I have to differentiate the power.
Oh, I thought after doing the 1 divided e to the negative x natural log of 4, then you differentiate right after that. So do you write it then differentiate? Sorry. Does that make sense?
So we have 1 over the function times natural log 4, because I'm differentiating log. It's a very good question. So first, let's decompose this because it's a very good question. Log base 4 of a function prime. First, let's not even look at what this is. Leave it alone for a moment. So I differentiate log base 4 of a function and I get 1 over the function, natural log 4, but multiplied by f prime. Is this okay so far? It's a very good question. But now, remember this is e to negative x. So then this becomes e to negative x prime. And when I differentiate e to negative x, I do get e to negative x times negative 1. Very good question. So, so I have the function, which is this one, right? It's e to negative x times natural log 4, but now times this, which is this.
Yeah, so I thought when you differentiate, you're not like you're doing it right when you see it. So you would do the 1 over the function times f prime. So it would be 1 over the function times, in this case, it would, I thought it would just be e to the negative x, not times negative 1. That's my bad.
No, because first, see, this is the outer function. This is the next function, and this is the next function.
Okay.
Outer, e to the x, with e to a power, and then the power.
Okay, that makes sense.
So there are 3 functions. So log base 4 of a function is 1 over the function times natural log times the function prime, which is this.
Okay, I understand now.
Better?
Thank you.
Thank you. Very good question. Good. Anything else you would like to go back to?
So I'm sorry, but so if The inner part of the function was e to the negative x times cosine pi x. Why didn't we include that in the denominator? It was
So that's why from the very beginning I said, is this a
Okay.
product
okay.
or
I didn't see your
or
your
is this?
parentheses.
So
Yeah.
that's very important. So that's why I was asking, is this, you understand it as a product or you understand it as log base 4 of this?
Right. I thought you were asking about the e to the negative x times cosine pi x because I didn't see your parentheses.
So that's why I need to know. Yes, that
Right.
was my first question, whether this
No, I
is a
know.
product.
I misunderstood though.
Okay, so then running out of time. So in a few minutes I'll stop and create another meeting. Sorry about that.
Yeah, no, it's fine. I think I found my error in it. So unless somebody else
So
wants to see it reworked out, then
okay, so was it like this
no,
or was log of the product?
log of the product.
Okay, so this is fine as it is right now. So
Yeah.
let's do the other one. Sorry.
No, it's fine. I just couldn't see the
Yeah, that's why I
parentheses.
said from the very beginning, is the product, then I use the product rule. If it's not the product, then I cannot, I will still use the product rule, but inside log. So this is the situation then. Is that correct?
Yes.
Okay. So this is correct as is. Now we're going to solve, we're going to differentiate something else. Okay, perfect. So y prime. So this is the function now. So it's 1 over the function times natural log 4. And now e to negative x prime is e to negative x times negative 1 times cosine pi x plus e to negative x times negative sine pi x and times positive pi. And I'll try to simplify a little bit by factoring out e to negative x and canceling it with this. So the numerator becomes just negative cosine pi x, and this is negative pi sine pi x, and everything divided by cosine pi x natural log 4.
Okay, thank you.
Thank you. Is this better?
Yes.
Okay, perfect.
For after negative sine pi x, is that a plus x or?
So it's plus, but it will automatically change into minus because there is a minus here. And e to negative x is outside, simplified with this. I factor out e to negative x. So from the first term, I only have this. From the second term, I only have this.
I mean, for the after negative sine pi x, it's hard to tell what that is. Is that a pi?
This one here in front.
Yes.
This one here.
Oh, all right. All right. Thank you.
Thank you. Sorry about that. Very good questions. Anything else you would like to work on? I'm going to stop the video and then